Okay, so for this problem, we want to find the area bounded by the curves y equals x squared and y equals x plus 1. So something that was different from this problem to the other two is that for this problem, we actually had the limits of integration. This is started from x equals 0 and ended at x equals 4. This one started at x equals -1 and it ended at x equals 2. But for this other problem, we don't know where it starts and where it ends. So since we're looking for the area bounded between the curves, in order for me to find where they intersect, so let me write, where do they intersect? One of the things that you want to do is set them equal to each other. So set them equal and solve. Okay, so you want to take x squared minus 5 and set it equal to x plus 1 and then solve this. Now I can move, since I know this is going to be a quadratic, I can move all of my x's together. I can move my x's. I can get x squared minus x minus 5 equals 1, and then I'm going to subtract by 1 to both sides, and then I'm going to get x squared minus x minus 6 equals 0. Okay, after that I can just factor this out. So I have x and x, so two numbers I multiply to get 6 and add up to get -1 will be -3 and plus 2. And then when I solve this, I'm going to get x equals 3 and x equals -2. So now I know where exactly they both intersect. So my two graphs intersect at x equals -2. So here's -2, and at x equals 3. So this is where they're both going to intersect. Now, sometimes it can be really, the problem can be a little bit complicated. Something that you can also do is plot both of them. So a second approach that you can do is use table function to graph. And then you can try to figure out where exactly they're both going to intersect. So that can be a little bit harder because you do not know if it's going to be at 10 or 100. So you have to kind of look to see where they're going to have equal y values. But this is actually the faster method, just solving it straight up. So now the only thing that I'm just missing is that I do not know what these graphs look like. Well, this one's easy. So let's just call that one my blue graph. So my blue graph is going to be y equals x plus 1. So I'm going to start off at 1, and then after that, I'm going to go up 1 over 1, up 1 over 1. Okay, so my graph is going to look something like this. So it's going to go up 1 over 1, then I'm going to continue, and then I'm going to continue. So, and then this one, I'm just going to continue downward. So here's that -1. So my graph is going to look something like this. Okay, so that's basically what it somewhat looks like. Or you can use a table function and you can plot different points. Then my other one, let me call this one red. This is just going to be at x equals x squared minus 5. This one actually is going to look like this. All the way down, it's going to be at -5 because this is a parabola going downward, and then it's going to be going upward. So here at -4 is going to be 1 and 1, and then at -2 it's just going to go all the way up here. Okay, so it'll look something like this. So my graph will look something like this, and it'll intersect at 3. Okay, so if you do not quite know what these look like, then just go ahead and just use a table function. Okay, and then you can plot a couple points between -2 all the way to 3. Okay, so now let's go ahead and find this area. So this area is going to be the area bounded by this two different graphs. We clearly see that the upper graph is going to be my line. So my area, is going to be the integral from -2 all the way to 3. My upper function is going to be my x plus 1. And my lower function is going to be this x squared minus 5 dx. Okay. So now let's go ahead and solve this. I'm going to have integral from -2 to 3, x plus 1 minus x squared minus 5 dx. So this is going to be integral from -2 to 3. I can combine my 1 and my 5. what is that going to give me? That's going to give me a negative 4. Then I'm going to get a plus x and then minus x squared dx. Okay, and from here I can just go ahead and integrate this. This is going to be negative 4x plus x squared over 2, and then minus x cubed over 3. And this is going to be from negative 2 to 3. Okay, so I'm almost done with this integration. I can just go ahead and use the fundamental theorem of calculus. So I'm going to plug in x equals 3 first, and then I'm going to subtract it by plugging in x equals negative 2. So my first one's going to be, what? It's going to be negative 4 times 3 plus 3 squared over 2 minus 3 cubed over 3. Then this one's going to be plugging in this negative 2. I am going to have negative 4 times negative 2 plus negative 2 whole quantity squared over 2 minus negative 2 whole quantity 3 over 3. Okay, so that's what I got. And now when I go ahead and put this in my calculator, what am I going to get? And what I end up getting is negative 175 divided by 6, or this is just approximately negative 29.17. Okay, so these are the numbers that I ended up getting. Okay, so this one was a little bit not as involved as the other one. The only thing that you really needed to do is just solve this equation, okay, to find our bounds. And then once we find our bounds, we can just use our table function to graph them. Or if we know how to graph this parabola and this line, then it should be pretty simple. Okay, so that's the 3 different cases of how to find areas between curves.